Have you ever stopped to think about how your favorite video game works? Or, the apps you use on your phone every single day? Well, the secret behind most of them is a big idea called object-oriented programming, or OOP for short. Now, I know it sounds super technical, but it's basically the blueprint that powers almost all the software we use. So let's break down how it all works.
Right. So how do we actually get from a bunch of text on a screen to a character that can run and jump and interact with a whole world? The answer is actually pretty elegant, and believe it or not, it all starts with one powerful idea. And that's the secret right there. The best way to get this is to think like an architect. Seriously, to understand how software gets made, we're going to imagine we're building a house. Because before you can even think about laying a single brick, you need a really detailed plan. You need a blueprint.
Okay, so in this first part, we're going to explore the two absolute cornerstones of this whole thing, classes and objects. We're going to stick with our blueprint analogy to see how a plan on paper turns into something real, something you can actually use.
First up is the class. Now, think of a class as that master blueprint from the architect. It has all the specs, how many rooms, where the windows go, what kind of roof it has. But here's the key. By itself, the blueprint isn't a house, right? It doesn't do anything. It's just the detailed plan for how to build one.
And that's where the object comes in. An object is the actual house that you build from that blueprint. And what's so powerful about this is that from one single blueprint, one class, you can build an entire neighborhood of totally unique houses. Each one of those houses is called an instance of that original plan.
So how does the actual building process get started? Well, that's the job of something called the constructor. Just think of it as the very first step on the construction site. It's this special set of instructions that pours the foundation and sets up all the initial features, like how many bedrooms it has, the moment it's being created.
Okay, so now we've got our blueprint and we've got our house. Next, we need to describe them, add some details. But not all properties are created equal. Some are unique to your specific house, while others might be shared across the entire neighborhood. Let's dig into how that works. First, let's talk about instance variables. These are the details that make your house, well, yours. Your house has a specific paint color, a unique address, right? These properties belong to that individual object, the house itself, and they literally can't exist without it. But then you've got static variables. These properties don't belong to just one house. They belong to the blueprint itself. A perfect example is the name of the construction company that built the entire neighborhood. That name is the same for every single house. There's only one copy of that info, and it's shared by everybody. And this visual just makes that difference crystal clear. On the left, you've got the unique stuff for each house. Those are the instance variables. And on the right, you've got the one shared property that applies to all of them, the static variable, which you'll remember belongs to the blueprint, the class itself. It's all about what's individual versus what's shared.
But what happens if you forget to tell the builders a detail? Like if you don't tell them what color to paint the house, they're not just going to stop working. Nope, they're going to use a default, a standard coat of primer. And programming works exactly the same way.
Just like that primer paint, every type of data in programming gets a default value if you don't give it one. Numbers start out as 0, true-false values become false, and more complicated things default to null, which just means empty. It's like a built-in safety net that helps keep your code from crashing. So we've covered the variables that describe the house and the blueprint. But what about the tools you use while you're building? The ones you just need for a specific task and then put away? Well, that brings us to our third type of variable. These are called local variables, and they're exactly what they sound like, temporary and super task-specific. The best analogy is a measuring tape. You take it out to measure a window frame, use it, and as soon as that job is done, you put it away. It only exists for the duration of that one specific task.
So the rules for these tools are pretty simple. They only exist inside a specific task, which programmers call a method. And unlike the house's properties, they don't get a default value. This part's important. You have to give them a value before you try to use them, or your program is going to complain.
Okay, so we've defined what our house is, all its properties. But what can it do? A house isn't just a pile of materials. You can open doors, turn on lights, run the water. These are the actions, and in programming, we call them methods.
So instance methods are the verbs of our programming world. They're the actions that a specific house can do. It makes sense, right? You can't open a door if there's no house to begin with. This means you absolutely have to have an object first before you can ask it to do something.
Here's a quick look at how that works in code. In step 1, we use that new keyword to build an actual calculator object from the calculator blueprint. We'll just call it C. Then, and only then, in step 2, can we ask that specific object, C, to do a task for us, like get the area. See? Build it first, then use it.
But what about actions that are related to the blueprint itself? Those are static methods. You don't need a specific house to ask a question like, hey, how many houses has this company built in total? You can just ask the blueprint, the class, directly, without ever needing to create a single object.
So we've covered a lot of ground here. But you might be wondering, why go through all this trouble with blueprints and objects and all these different variables? Why does this whole approach matter so much?
Well, it really all comes down to this. The whole blueprint idea isn't just about building one thing. It's about creating a system that's reliable, something you can reuse, and something that stays organized. It's what lets developers build these massive, complex applications without everything just falling into chaos.
All right, let's do a super quick recap to make sure this all sticks. The class, that's your blueprint. The object, that's the actual house. Instance variables are the unique features, like the paint color. Static variables are shared features, like the builder's name. And methods, those are just the actions, like opening a door.
And that's pretty much it. You now have the fundamental concepts for how almost all modern software is designed. The real power of a blueprint is its potential to create literally anything you can imagine. So the only question left is, what would you build?